Hey everyone, and welcome back for another deep dive.
Glad to be here.
Today we're going to be talking about something that I think is pretty important for anyone who's interested in cryptocurrency.
Yeah, definitely. I think this is a topic that a lot of people are talking about, but maybe not really understanding the full implications of.
Yeah, and that's what we're here for, right?
Mhm.
We're here to kind of like get down into the nitty-gritty.
Yeah.
So basically what we're going to be looking at is the potential impact of quantum computers on cryptocurrencies like Bitcoin.
Right. And how realistic that threat is and what it could mean for the future of cryptocurrency.
Exactly. And what's so fascinating is we've got some really interesting research that breaks down exactly how this might happen and some potential solutions. And the whole thing is just mind-blowing.
Yeah, it's a very complex topic, but it's one that's worth understanding because it could have a major impact on the way we use and think about money in the future.
So let's start with the basics. I mean, everyone knows that cryptocurrencies like Bitcoin are supposed to be super secure. But how does that security actually work? Like, what's the magic behind it?
Yeah, so it's not really magic, it's math.
Okay.
And really complicated math that most cryptocurrencies rely on incredibly difficult math problems for their security.
Okay.
It's not about being unbreakable. It's about how long it would take a normal computer to crack the code.
I see. So it's like a digital fortress with walls so thick that it would take a normal computer like centuries to break through.
Exactly.
But then along comes quantum computing, which is like this battering ram that could potentially smash right through those walls.
Yeah, that's a good analogy.
So can you explain this a little bit more? Like how do quantum computers actually threaten cryptocurrencies?
Sure. So one of the key math problems that a lot of cryptocurrencies rely on is something called the discrete logarithmic problem.
Okay, the discrete logarithmic problem.
Yeah, it sounds intimidating, but it's actually a pretty simple concept to grasp. Imagine you're trying to figure out how many times you need to multiply a specific number by itself to get a certain result. Now, imagine that number has hundreds of digits.
Oh, wow.
That's a problem that would take classical computers centuries, even millennia, to solve.
Right, because they have to go through each combination one by one.
Exactly. But quantum computers, because of how they work, can potentially crack it much, much faster.
Okay, so what makes quantum computers so different? Like, how can they do this when our normal computers can't?
So traditional computers use bits, which can be either a 0 or a 1.
Right, kind of like an on or off switch.
Exactly. Quantum computers use qubits, which can be both 0 and 1 at the same time.
Wait, what? How is that even possible?
It's a concept called superposition, and it's one of the things that makes quantum mechanics so mind-blowing.
So it's like they're running multiple calculations simultaneously.
Exactly, and that's why they have the potential to be so much faster than classical computers for certain types of problems.
Like cracking the codes that protect cryptocurrencies. Okay, so this is kind of scary stuff, right? Like if quantum computers can really do this, doesn't that mean that Bitcoin and other cryptocurrencies are basically doomed?
Well, it's not quite that simple. Quantum computers are still in their early stages of development.
Right.
And it's not clear when or even if they'll be able to crack the codes that protect cryptocurrencies on a large scale.
Okay, so there's still some hope.
There is, but it's important to be aware of the potential threat and to start thinking about solutions now.
So what are some of the solutions? Like how can we protect cryptocurrencies from quantum computers?
Well, one solution is to develop new types of cryptography that are resistant to quantum attacks.
Okay.
There's a lot of research going on in this area, and some promising candidates have emerged.
Like what?
Well, one example is lattice-based cryptography.
Lattice-based cryptography.
It's a type of cryptography that is based on the difficulty of solving certain problems involving lattices, which are mathematical structures.
And these lattice problems are hard, even for quantum computers.
That's the idea.
Interesting. So is anyone actually using this lattice-based cryptography?
Well, it's still early days, but there are a few cryptocurrencies that are starting to experiment with it.
Okay.
One example is Nexus.
Nexus.
Yeah, it's a cryptocurrency that was designed from the ground up to be resistant to quantum attacks.
And how does it do that?
Well, for one thing, it uses a much larger key size than Bitcoin.
Okay.
Bitcoin uses a 256-bit key. Nexus uses a 512-bit key.
So it's like a much bigger lock that's harder to pick?
Exactly. And it also uses a different hashing algorithm that is thought to be more resistant to quantum attacks.
Okay, so Nexus is like future-proofing itself against quantum computers.
Yeah, you could say that.
That's pretty cool.
Yeah.
But what about all the other cryptocurrencies out there that aren't using these quantum-resistant solutions, like Bitcoin, for example?
Yeah, that's a big problem.
I mean, Bitcoin is like the biggest cryptocurrency out there, right?
It is, and it's vulnerable to quantum attacks.
So what can be done?
Well, one option is to upgrade Bitcoin to use a quantum-resistant algorithm.
Okay, but is that even possible? Like, can you just upgrade Bitcoin like that?
It's not easy.
Yeah.
Bitcoin is a decentralized system, which means that there's no central authority that can just make changes to the protocol.
Right.
Any changes have to be approved by a majority of the network.
Which is probably not going to happen anytime soon.
It's unlikely.
So what does that mean for Bitcoin?
Well, it means that Bitcoin could become vulnerable to quantum attacks in the future.
And what would happen if that happened?
Well, it's hard to say for sure, but it could be pretty bad.
Yeah. I imagine it would cause a lot of chaos and uncertainty.
It definitely could.
So this is all pretty serious stuff.
It is.
But I'm curious, like, how far away are we from actually having quantum computers that can crack the codes that protect cryptocurrencies?
That's a good question, and the answer is that no one knows for sure.
Okay.
Quantum computing is still a very young field, and it's developing rapidly.
Right.
Some experts believe that we could have quantum computers that are powerful enough to break Bitcoin within the next decade or two.
Wow, that's not that far off.
No, it's not.
Other experts are more skeptical and believe that it could take much longer.
Yeah, it's possible.
But regardless of the timeline, the threat is real.
Absolutely.
And we need to start preparing for it now.
Exactly.
So what can our listeners do to prepare? Like, what are some practical steps that they can take?
Well, one thing they can do is to stay informed about the latest developments in quantum computing and cryptography.
Okay.
There are a lot of great resources available online and in the media.
Right.
They can also start thinking about diversifying their cryptocurrency holdings.
So don't put all your eggs in one basket.
Exactly. And if they're interested in investing in cryptocurrencies, they should definitely do their research and make sure that they understand the risks involved.
Including the risk of quantum attacks.
Right.
So this has been a really fascinating and somewhat terrifying deep dive into the world of quantum computing and cryptocurrency.
Yeah, it's definitely a topic that's worth keeping an eye on.
And I think the big question that we're left with is, what does the future hold? Like, if quantum computing really does become as powerful as some people predict with, we need to completely rethink our approach to digital security.
It's definitely something to think about, and I think it's a question that we'll all be grappling with in the years to come.
So thanks for joining us for this deep dive, and we'll see you next time.